Hello everyone, my name is Pyarasani Bharat from ITA section. Today I am going to discuss about object-oriented and conventional analysis and design methodologies. Understand the principles of object-oriented and conventional software design. Software design methodologies provides structured framework for system development. They define symmetric approach to analyzing, designing, and implementing software. Two primary categories include conventional and object-oriented methodologies. Understanding both helps in selecting the right approach for a given project. Conventional methods follow a linear or sequential flow, often known as waterfall model. They emphasize functional decomposition and process-based design. Systems are divided into smaller independent modules based on functions. Data and behavior are treated as separate entities. Focuses on step-by-step development from requirements to implementation. Processes and data are modeled independently using tools like DFTs and ER diagrams. Emphasis are placed on algorithms and control structures. Limited flexibilities for accommodating changes during later stages. Difficulty to manage complex systems with interdependent data and behavior. Poor adaptability to changing requirements or iterative development. Lack of emphasis on data abstraction and reuse. Maintenance and scalability are challenging in large projects. Object-oriented methodology integrates data and behavior into single entities called objects. It models real-world entities using classes and objects. The approach supports modularity, abstraction, and reusability. It provides a more natural way of designing complex systems. Key concepts include classes, objects, inheritance, encapsulation, and polymorphism. Classes define the structure and behavior of objects. Objects interact through messages and methods. These features promote reusable and maintainable software architectures. OOA identifies objects, these attributes and relations from problem statements. Emphasizes modeling based on real-world entities rather than functions. Helps in understanding how system components interact conceptually. Results in object models that guide further design and implementation. OOD focuses on defining software architecture using object-oriented principles. It involves class hierarchies, design patterns, and interface design. OOD aims to enhance modularity and reduce coupling between components. Serves, it serves as a bridge between analysis and analysis models and code implementation. Object models uses diagram to represent system structure and behavior. Common modules include class diagrams, sequence diagrams, and use case diagrams. These models describe how objects collaborate to achieve system functionality. Modeling simplifies design communications among developers. OOA focus on objects and their interactions. Conventional analysis focuses on functions. OOA integrates data and behavior while conventional separates them. Object-oriented models are easier to extend and maintain. The conventional models are simpler but not flexible for evolving systems. Okay. Promotes modularity and reuse through encapsulation and inheritance, simplifies maintenance and extension of existing systems, encourages abstraction and better real-world modeling, supports scalable and robust robust software architectures. UML provides a standard notation for visualizing and documenting object-oriented designs. It includes structural diagrams like class and components diagrams, behavioral diagrams such as sequence and activity diagrams, model system interactions. UML enhances clarity and communication during design development. Encapsulation hides internal object details and exposes only essential interfaces. Inheritance enables class hierarchy, promoting code reuse. Polymorphism allows dynamic method binding and flexible interface use. These concepts collectively enhance software design efficiency. Modularity divides systems into well-defined independent components. Reusability reduces redundancy and speeds up development. Object libraries and frameworks simplify reusability in practice. Both, both features contribute to maintenance and scalable software solutions. Design patterns offer reusable templates for solving recurring design problems. Examples include singleton, factory, observer, and adapter patterns. They enhance consistency and reduce design effort across projects. Design promotes embody best practices in object-oriented design. OOPS life cycle includes analysis, design, implementation, testing, and maintenance. Each phase emphasizes object-oriented principles and iterative reformation, reformment, encourages continuous improvement and flexibility in development. The life cycle aligns well with agile and incremental development models. Super learning curve compares to procedural methods. It requires understanding of abstraction and class hierarchies. Transitions in legacy systems to OOP can be complex. Tools and processes adaptation is necessary for full integration. Demonstrates how procedural systems can be reconstructed using classes and objects. Highlights benefits such as reused code, duplication, and better maintainability. Shows gradual migration using hybrid approaches. Validates the efficiency of object-oriented design in modern software systems. Object-oriented methodologies unify data and behavior, enhancing modularity. Conventional methods focus on processes decomposition but lack flexibility. OOP offers better usability, scalability, and maintainability. Adopting OOP design ensures sustainable and efficient software development. Reference Grady Botch, Object-Oriented Analysis and Design with Applications. James Bounds, Object-Oriented Modeling and Design. Usman, Software Engineering, a practitioner, which Department of IT. Thank you.